Hello, good evening. My name is Raymond A. Vehar, and this is Society's Banking Industry Security Frameworks here at Grand Canyon University, CYB 690 Cybersecurity Program Development. And the purpose of this presentation will be to demonstrate how to implement the NIST Cybersecurity Framework to identify and close gaps between society's banking industry's current cybersecurity status and its future cybersecurity status while aligning with the Payment Credit Card Data Security Standard regulation. And here's our objectives. We're going to explain the current cybersecurity environment, such as development process paradigms, information configuration management, and system directly involved in delivery services. We're going to describe the current risk management practice, development threats, legal and regulatory requirements, business/mission objectives, and organizational constraints using the framework identified. We're going to describe how security's best practices and frameworks can be used as a reference to develop a cybersecurity program. We're going to create a diagram related to the common workflow of information and decisions at the major levels within our organization. And we're going to explain the critical cybersecurity needs that should be in place to ensure compliance with the appropriate regulation by differentiating from the NIST, ISO, and then we have the PSI, DSS regulations, PIPA regulations, SOX regulations, the GLBA regulations. And then we're going to prioritize our organizational efforts, business needs, and outcomes. And then finally, we're going to list and describe the elements of our software assurance maturity model. That's basically what we'll be learning throughout this presentation. We're going to start with our current cybersecurity environment. So, society's banking industry's current cybersecurity environment is a complex ecosystem encompassing various interconnected elements that work together to protect our sensitive information and systems from cyber threats. It involves a combination of secure development practices, information security principles, configuration management, and systems that directly impact our service delivery. So our cybersecurity configuration management is the process of ensuring that security configurations on all of our banking systems are consistently and appropriately configured to minimize our specific risks. Our development process involves several key stages that include our risk assessments, implementation of our security controls, ongoing monitoring, and improvements. So our company is shifting from the traditional perimeter-based cybersecurity models to modern paradigms like zero trust, behavioral analytics, and AI-powered solutions. Our information, the banking industry holds a wide range of cybersecurity information that includes personal data from names, addresses, financial details, and transaction records, while maintaining our information about our own systems, our network security protocols that include logs of user activity, network traffic, and security audits. Finally, our system directly involved in our delivery of services, we create a multi-layered cybersecurity approach that incorporates techniques that include multi-factor authentication, encryption, and AI-powered threat detection to protect our customer data and transactions. In addition to this multi-layer cybersecurity approach, the bank relies on a robust network and security measures that include firewalls, intrusion detection systems, while implementing our policies, conducting audits, and training our employees to enhance our security posture. Again, this is our current cybersecurity environment. Next, it is imperative to understand how the NIST cybersecurity framework is structured, as it'll help later throughout this presentation to understand how our company will align it with the payment card industry data security standards. And as you can see here, the NIST cybersecurity framework provides a structured approach to managing cybersecurity risk. It is based on five core functions: identify, protect, detect, respond, and recover. These functions help organizations understand, manage, and reduce an organization's cybersecurity risk. And to the right here, you can see the tiers and profiles are used to help organizations assess and improve their cybersecurity posture. Tiers represent the maturity of an organization's cybersecurity practices, while the profiles define how an organization aligns its resources and objectives to achieve specific outcomes within the framework. For instance, we just got done looking at our current cybersecurity environment. So when we're working with tiers, tier one could be our current cybersecurity environment. And eventually, Tier 4 will be the payment card industry data security standards. So here's the payment card industry data security standard regulation. The payment card industry data security standard is a global recognized security standard designed to protect cardholder data and reduce payment card fraud. It's essentially a set of requirements for businesses that handle credit and debit card information, ensuring that they maintain a secure environment and protect sensitive information. And here are the requirements for technical and operational requirements that include securing networks, protecting cardholder information, maintaining a vulnerability management program, implementing strong access control measures, and then regular monitoring and testing networks and maintaining an information security policy. Thus, society's banking will use the NIST cybersecurity framework to help align with the PCI DSS by providing this structured approach to risk management and security controls, which can then be mapped to specific PCI DSS requirements. So here we're describing our current risk management practice, development threats, legal and regulatory requirements, business slash mission objectives, and organization constraints using, again, the framework that we chose is the NIST cybersecurity framework. And this is our current risk management practices. So our organization would use the cybersecurity framework to systematically manage our cybersecurity risks, mapping our current practices against the framework's five functions. Again, as you can see here, to the left, you got identify, protect, detect, respond, and recover. So thus, we're addressing our developmental threats, legal, regulatory requirements, our business objectives, and organizational constraints. This approach provides a structured, repeatable process for improving our cybersecurity posture and aligning it with our specific banking needs. So, for instance, our current risk management practice, this is our organization needs to understand its current cybersecurity capabilities, including our policies, procedures, tools, and resource allocation. So, our threat environment, we want to identify our specific potential threats, including our internal and external actors, our vulnerabilities, and supply chain risks. Our legal and regulatory requirements ensures compliance with relevant banking specific regulations such as the GDPR, the PCI, DSS, and et cetera. There's many more. Our business slash mission objectives aligns with our cybersecurity effort with our bank's strategic goals and risk tolerance. And then our organizational constraints. This would be considering our limitations, I'm sorry, from budgeting, staffing, and technological infrastructure. So here's an example of exactly how we're going to do the mapping. How society's banking industry uses the NIST cybersecurity framework to align with the payment card industry data security standard regulations. So again, here are the five functions of the framework. We're going to start with the identify. So we're going to utilize the identify function of the NIST CSF to map PCI DSS requirements to specific assets and risks of our bank from payment systems, our networks, and cardholder data. We've got the protect function here. We're going to implement the protection function to establish security controls that meets the PCI DSS requirements to such as we had listed on The slide before were firewalls, intrusion detection system, encryption, and access controls. Moving on to the detection function. The detection function is used to establish security monitoring and incident detection capabilities to identify the PCI DSS compliance breaches. A respond function is used to establish incident response plans, procedures to handling PCI DSS compliance violations or security incidents. And then finally, we got the recovery function. And the recovery function is used to develop business continuity and our disaster recovery plans to ensure that our payment processing systems can be restored in the event of a security incident or disaster. Uh, Next, we got to describe how our cybersecurity best practices and frameworks can be used as a reference to develop a cybersecurity program. So, cybersecurity frameworks, as the one that we mentioned before, which was the CSF, and best practices provide a structured approach to building a cybersecurity program. They offer a roadmap for identifying your risks, establishing your policies, and implementing security controls, but ultimately leading to a more robust cybersecurity posture. By using frameworks as a reference, organizations can align their existing or new cybersecurity program with industry's best practices, regulatory requirements, improve risk management, and demonstrate due diligence. So here's how to use a cybersecurity framework and best practice to develop a cybersecurity program. You're going to start with conducting the risk assessment. And this is understanding your specific risks and vulnerabilities to your specific organization and goals. You're going to select a framework. Framework should align with an organization's size, complexity, industry, and specific needs. And here's a few others. The ISO 27000, the CIS security controls. These are a few other frameworks that could be used. And then you're going to develop a cybersecurity strategy. You want to align the cybersecurity program with the organization business goals and risk appetite. You're going to develop policies and procedures. This is based on your risk management and selected framework. You're going to implement your controls. Implementing controls are recommended from the chosen framework and tailored to specific needs and your environment. You're going to do continuous monitoring and improvement. You want to regularly assess the effectiveness of your cybersecurity program. You want to continually identify areas for improvement and adapt your controls as needed to stay ahead of the continued evolving threats. So we got our common workflow of information and decisions. Our bank's diagram depicting our information and decision workflow uses our hierarchical structure with decision-making authority at the top and information flows down to various levels. This diagram would show the flow of information from our branches to regional managers, then to our heads, and finally to our senior management. The diagram would also show how a decision flows from our senior management all the way down to various levels. And then let's take a look here. Just kind of go over, as you can see, our top level. So senior management, CEO, CFO, COO, and as you can see, the information, decisions, and policies from senior management are communicated down to our regional heads, who then disseminate them to our branch managers and other staff. So it would flow downwards. Here's our regional heads or department heads. So information can flow horizontal between departments or regions, such as credit departments sharing information with branch or regional heads seeking feedback from other regional departments. And as you can see, here's the departments. It flows horizontal and it's coming down from our senior top management. As it goes down here, this is our lower level branch managers, team leaders, and individual employees. Our data from branch managers, this could be our customer accounts, transaction history, financial reports, which would then flow back up to our regional heads who compile it into reports for our senior management. So again, they file the reports here, for our regional heads and departments, and it goes back up to our top level management who make the decision and policies. Policies. I apologize. So, our critical cybersecurity needs that should be in place to ensure compliance with the appropriate regulations by differentiating from NIST, the ISO, and here's the regulations that we spoke of before, and to ensure compliance with regulations like the PCI DSS, HIPAA, SOX, and the GLBA. Organizations must go beyond basic security controls and implement specific measures tailored to each of these regulations. So while the NIST and the ISO series provide foundational frameworks, these regulations often require additional specialized controls. And here goes examples of each of the regulations to be in compliance with these regulations and standards. So the PCI DSS focuses on securing cardholder data, requires specific controls. Again, this should be familiar firewall configurations, protect the network perimeter and individual systems from unauthorized access, data encryption, protecting holder data at rest and in transit, access control, limiting access to cardholder data based on the principle of least privilege. And we got the HIPAA regulation, that's protecting protected health information, PHI. This requires secure data storage, ensuring that PHI is stored securely and access is limited. Secure data transmission, using encryption and secure methods for transmitting PHI. Business associate agreements, establishing clear responsibilities for handling PHI with third parties. The SOX, ensuring financial reporting accuracy and integrity. This requires our access controls, limiting access to financial data and systems. We got our auditing, implementing a robust auditing procedures to ensure compliance, data validation, verifying the accuracy of financial data. And we got our GLBA, this is protecting consumer financial information. This requires data encryption, protecting financial data at rest and in transit. Access controls, limiting access to financial data and system based on the principle of least privilege, and in security training, educating employees about the GLBA compliance. And again, these are the requirements to make sure that your company is in compliance with the appropriate regulation depending on your specific organization. Next, we got the elements of a software assurance maturity model. So, society's banking industry software assurance maturity model, SAM, is a framework created by the Open Web Application Security Project that helps organizations assess and improve their software security posture. It is structured around five core business functions: the governance, design, implementation, verification, and operations. Each encompass three security practices, thus resulting in a total of 15 practices. Thus, these practices are then further divided into streams of maturity levels, allowing a detailed analysis and improvement of security across the whole software development lifecycle. And here we go, the five core functions. And then we have the three security practices here. And then it'll total 3, 6, 9, 12, 15 for the total of 15 practices. And here's a breakdown example of a software assurance maturity model, how we'll use those five functions. So governance, the purpose is to establish security policies, procedures, and a culture of security awareness within the bank. We're going to use examples: security awareness training, risk management, and a secure build pipeline. Our goal is to create a foundation for security practices and to ensure that everyone understands the importance of security. Design function, we're going to secure our architecture, designing secure architectures and systems. Our security requirements, we're going to define security requirements for our software. We're going to design review, review design for security flaws, implementation, secure coding, implementation, secure coding practices, code review, reviewing code for security vulnerabilities or vulnerability management, identifying and managing security vulnerabilities. We got our verification function, security testing. We're going to conduct security testing to identify our vulnerabilities, our static and dynamic analysis, analyzing code for security vulnerabilities, environment hardening, ensuring the security of the development environment, and finally our operations. We're going to issue management, managing security incidents and vulnerabilities, our environment hardening. Again, we want to secure the production environment, our operational enablement. We're going to provide support for security operations. This is the end of this presentation. I hope you found it informative and I want to thank you for your time.